Hey guys, so I wanted to make a quick video to re-go over some of those transformations that we talked about in class. So what I did here is I went ahead and put the table first, okay? And so as you can see, it goes vertical translation, horizontal translation, vertical stretch and shrink, horizontal stretch and shrink, and then we will end with a reflection. So the first column shows you the transformation. The second column shows the effect of the graph. And then the last column shows you the change to points for your function. Okay? So what I'm going to attempt to do this time is I am going to explain this by a square root function. So why does this work? Why does the graph do what it does? So I'm gonna attempt to show you by the square root function. However, before we get started, we have to talk about things about the square root function because I need to make sure that we're all squared away with the square root function. So the first things first, it's f of x equals the square root of x, okay? Now, I know in class we've talked about it. The square roots we cannot take the square root of a negative number. So we have talked about that the domain has to be 0 or bigger because we can't take the square root of a negative. So let's think about what we have here. The square root, so let's do this. Let's do an x column here. I'm going to put the square root of x here as my work, and then these are going to be our y values. So if I plug in 0, I get the square root of 0, which gives us a 0, which means we will have the ordered pair 0, 0. If I plug in 1, I get the square root of 1, which is a 1, so we're going to graph the ordered pair 1, 1. But I can't take the square root of 2. We don't know what the square root of 2. Yes, you can pick up your calculator and go get the decimal, and that is fine if you want to do that. But I'm trying to make sure this all stays pretty, no decimals for the most part, okay? So we can't take the square root of 2, we can't take the square root of a 3, but we can take the square root of a 4. And the square root of 4 is 2. So our next ordered pair would be 4, 2. We can't do 5, square root of 5, square root of 6, square root of 7, square root of 8, but we can do the square root of 9, which gives us a 3. So this ordered pair would be 9, 3. These are the main ones that we are going to deal with today. So if you think about it, and I had a graph, 0, 0 would be here. You might have 1, 1 right here. 2, 3, 4. We're at a 2. And of course, I can take that out farther. Okay, so that is what a square root function is. Now, I want you to think about it. We talked about the domain, but what would the range be? Well, if we go from the bottom up, that first value we hit is 0, and then my graph continues to go up. And you can see that right here. This is the lowest y value we have, and then this y values can keep going. Okay, so this is what I want you to do. As we go through the lesson, I want you to think about these numbers, especially what can I take the square root of. So can't take square roots of negatives, but I can take the square root of 0. I can take the square root of 1. I can take the square root of 4, and I can take the square root of 9. Okay? So the first thing we're going to do is we are going to apply the vertical shift. So notice the vertical shift takes place on the outside of the graph. So I am going to do the original in blue. So if I plug in a 0, the square root of 0 is 0. So I'm going to put a 0 right there. If I plug in a 1, the square root of 1 is 1. We know that our next number is 4. The square root of 4 is 2. The square root of 9 is a 3. So for our original function, we have 0, 0, 1, 0, 2, 3, 4, 2, and then 9, 3. So there is our original function. And we will regraph that throughout the lesson. Oops. Okay, so this next part, notice where that 2 is located. So I'm still going to plug in the originals because notice it's the square root of whatever x is, then we're subtracting 2. So the square root of 0 is 0. 0 minus 2 gives us a negative 2. Square root of 1 is 1. We subtract 2, we get negative 1. Square root of 4 minus 2 is 2 minus 2, which gives us 0. Square root of 9 is 3. 3 minus 2 is 1. So here we go. 0, we are at a negative 2. 1, we're at a negative 1. 4, we're at 0. And 9, we're at 1. So notice what happens to our graph. Okay, we went down 2 units. And notice the placement of that negative 2. It is on the outside. So it did exactly what we thought it was going to do. It went down. Okay. The next one we're going to do is a plus 3. So we're still going to plug in our original x's because I know what the square root of 0 is. That's 0. And 0 plus 3 is 3. I know what the square root of 1 is, so I can do that. Square root of 1 is 1 plus 3 is 4. I can take the square root of 4, which is 2. 2 plus 3 is 5. I know what the square root of 9 is. That's 3, and 3 plus 3 is 6. So notice what happens now. We have 0, 1, 2, 3. We have 1, 4. We have 4, 5. And then we have 9, 6. So there's our graph. So notice from the blue graph, we went up 3 units. Okay, so I want you to think about what happened. Oh my gosh, I am so sorry. I want you to think about what happened. I'll put it right here off on the side. Notice graphs moves up or down, and which means we have a change in y values. Okay, so if I came back up to that first page, notice shift up, shift down, changes in the y values. Notice none of our x's changed at all. Okay. Okay, but now let's compare that horizontal shift. Okay, notice that this time the plus and the minus sign is in the inside. Okay, now notice this table. This table is a little bit more crazy. Okay, so we're going to start off right here with our original. So we know the square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. So I am going to go ahead and graph those points again. Okay. Okay. So let's start with this g of x. Notice what happened here, okay? I had to put another column of x because something's about to happen. I want you to think about this. If I go and I plug in 0 plus 6, that gives me the square root of 6. Okay, I would have to pick up my calculator and I would have to go figure out what that decimal is so I can graph it. And that is completely okay. But I want you to try to think of this, okay? We have the square root of x plus 6. The first square root that we need, probably not going to do an equal sign right now, is the square root of 0. So what would x have to be right here so that when I add 6 to it, I get a 0? Okay, hopefully you told me that x would have to be a negative 6. Because if x is a negative 6, negative 6 plus 6 is 0. Then I can take the square root of 0 and get a 0. Okay, so then let's look at it again. What would x have to be so that I can get the square root of 1? So x plus 6 gives me 1. What would that number right there have to be? And hopefully you said it, negative 5. Then if I put a negative 5 there, negative 5 plus 6 is 1. The square root of 1 is 1, okay? So let's do it again. What would x have to be so that when I add 6, I get the square root of 4? So if you're like, Miss Laurels, I'm still not getting it, that's okay. Set x plus 6 equal to 4. Well, subtract 6 from both sides, so x would have to be a negative 2. So that when you plug in a negative 2 and you add 6, we can take the square root of 4, which gives us a 2. Okay. So the last one, x plus 6, would give me the square root of 9. So what would x have to be so that when I add 6 to it, I get a 9? Well, hopefully you said 3. And then the square root of 9 is 3. Let's do one more. Okay. The next perfect square would be a 16. What would x have to be so that when I add 6 to it, I would get 16? Well, hopefully you said 10. So if I plug in 10, 10 plus 6 is 16. The square root of 16 is 4. Okay. So let's go look at our graph. We have 1, 2, 3, 4, 5, 6, 0, negative 5, 1, negative 2, 2, 3, 3, and 10, 1, 2, 3, 4. Oops, that's not a 4. I forgot that was a 9. So it's going to be out here. Okay, but notice what happened to the graph. We went left 6 units. So I went this way for when the problem said square root of x plus 6. So we did all the math, but notice what happened. The graph went left. So remember I talked about in class that when there's a plus 6 on the inside, you're going to want to say right, but when it's inside the function, it's opposite of what we think. It goes left 6 units because that plus 6 is on the inside. Okay, the last one, notice what's in the inside. It is a plus 1. So we have to do the same thing. We can't use those original x's because again, if I go plug in 0, yeah, 0 plus 1 gives me 1, but that's not the first one I need. The first one I need is 0, okay? So we have to go x plus 1. I need a 0. So what does x have to be to give me a 0? Well, hopefully you said negative 1. So the square root of a negative 1 plus 1 is becomes square root of 0, which is 0. Okay, now we're going to do it again. What would x have to be so when I add 1, I get 1? Well, we just kind of did that one. It ended up being 0. So if I plug in a 0, I get a 1. The next one I need is a 4. What would x have to be so that when I add 1 to it, I get a 4? Oh no, we're going to have to scratch that. These notes are not correct. Hold on a second. You don't have to erase everything, just those. I'm not going to restart the video, but I was about to say this is going the wrong direction. This is supposed to say square root of x minus 1. So I got to change these to minus 1s real quick. So let's go back and fix that. So if I want to have the square root of 0, what number minus 1 gives me 0? That's a 1. Okay, so this one would be 1 and then 0. X minus 1. What would x have to be so that when I minus 1, I get 1? Hopefully you said 2. 2 minus 1, square root of that is 1, and then we get a 1. So this is 2, 1. Now we'll go back to the other one that we were doing. What number minus 1 gives us 4? And hopefully you said 5. 5 minus 1 gives us the square root of 4. Square root of 4 is 2. I'm glad I caught that. Okay, so the next one would be 9. X minus what would give us 9? So x would have to be 10. The square root of 9 is 3. Okay, so here we go. We got 1, 0, 2, 1. Ooh, these are a little close right here. 1, 2, 3, 4, 5 right here. And then we're going to be at 10 way out here. So these were a little close. Sorry about that. Okay, but notice what happens when I graphed x minus 1. Okay, not that right there. We went to the right. So we went right 1 unit. So I want you to think about things that we did. Okay, so 1, we minus from x. Notice that all we did was move left and right, left and right. So if we're moving left and right, then that means we're affecting our x. This one, we add to our x because we're moving to the right. Even though it says minus, notice what happens to the math. We have to move right. Okay, so hopefully all that together minus my typo will help you guys a little bit on the horizontal. Okay, because remember on the inside we think opposite of what our brain wants to think, but also when you're looking at the math, that's the reason why. Okay, let's go look at the next one. So again, we are going to graph our original. Okay, so we have 0, 0, 1, 0, 4, 2, 9, 3. Okay, so we are going to start with this g function. Okay, notice we don't have anything going on the inside, so I don't have to go mess with my x values, okay, because it's just an x on the inside. So we have 2 times the square root of 0. So the square root of 0 is 0. 2 times 0 is 2. Okay. So, OMG, 0. Haven't finished my coffee. Okay, so then we have 2 times the square root of 1. Square root of 1 is 1, so 2 times 1 is 2. There is our 2. 2 times the square root of 4 is 2 times 2, which gives us 4. 2 times the square root of 9, which is 2 times 3, which gives us 6. So I want you to see what happens here. We're at 0, 0, but then I'm at 1, 2. Then I'm at 2, 4. And then here I'm at 1, 2. I'm over here at that 6. Notice what happens. Our graph is stretching. We're going higher, faster. Okay? But let's go look and see what happens when we put a half there. Okay? So we have a half times the square root of 0. Well, the square root of 0 is 0 times 0 is 0. 1/2 times the square root of 1. Well, the square root of 1 is 1 times a half is a half. Okay. 1/2 times the square root of 4. Well, square root of 4 is 2. Half of 2 is 1. 1/2 times the square root of 9. Well, the square root of 9 is 3, which gives us 3/2 or 1.5. Okay, so now when we go graph this, we're going to have to graph some fractions, which is fine because I didn't want to change our x values. So we got 0, 0. 1/2 is going to be about right there. Then we're going to have a 1 at that 4. And then over at our 9, we're going to have that 1.5. So notice our graph got squished down more. It compressed. It shrank. Okay. So this is your shrink. Oops, I should put a V there for at least vertical. This is your vertical stretch. But I want you to think about what also happened. Okay, so I'll write this one right here. So for this vertical stretch, we got higher faster, which means our y values changed. Okay, this is our vertical shrink. We were slower, but the y values still change. Okay, now here's the thing I want you guys to notice. Okay, when I did the vertical shift, notice I only had one x to deal with. Okay, because we just took the square root of x. We just did the square root of x. But when we came down here into this section, notice that things were added inside the function. So I had to make a new table for my x's. My x value that I plugged in had to change. Okay. Notice when I did the vertical stretch and the vertical shrink, nothing was inside with that x, so I did not have to technically make a new x column. But notice about what's to happen with these horizontals. Horizontal stretch and shrink, the inside of the function changed. So notice on this one, I had to do more x columns because my x has to change to give me the output that I desire. Okay, so let's go try this one real quick. So I'm still going to do my 0, 1, 4, and 9. So the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. And so I'm going to go graph those. Okay. So we're going to start with this one right here. So this is what I want you to remember. And I'm going to kind of ask you kind of the same thing that we did last time. If I have the square root of 2x, I know that I need that inside to be 0. So what would x have to be to give me that 0? Well, kind of like what I showed you a while ago. You could go 2x equals 0. Opposite of that is dividing. So 0 divided by 2 gives us 0. Okay, so how about I write it 2x equals 0. X equals 0 divided by 2. So x is 0. Okay, so my x value would have to be 0, then the square root of 0 is 0. Okay, 2x again, but this time I need it to be a 1. So kind of think of it the same thing. 2x has to be a 1 so that I can take the square root of that. Well, if you need to, divide by 2. So notice what happens. X is 1 divided by 2, which is a half. So my x has to be a half, so that when I plug that in, 2 times a half gives me the square root of 1. The square root of 1 is 1. Okay, I'm going to erase that part because I'm going to run out of room. If I have 2x and I need that to give me a 4, okay, this one's a little bit easier to see because I'm going to ask you, what does x have to be to give me a 4? Well, hopefully you're going to say 2. Well, that is because we divide both sides by 2. X equals 4 divided by 2, and that reduces to a 2. Okay, so if I plug in a 2, the square root of 4 is 2. So let's do one more, well, maybe 2 more. Square root of 9. So what would x have to be to give me 9? Well, again, if you don't see it, that's okay. Divide by 2, divide by 2. X would have to be 9 divided by 2, which is 9 over 2. Okay, and if I show it over here, 2 times 9 over 2, 2's cancel, square root of 9 is 3. So this one is 9/2, 3. But I do think I want to do one more. Okay, I'll squeeze it up here. Square root of 2x has to equal the square root of 16. So 2x would have to be 16. And some of you guys are like, well, x has to be, and hopefully you said it, 8. And that is because when we solve the equation, we have to divide by 2. And then 16 divided by 2 is 8. Okay? So if I plug in an 8, 2 times 8 is 16. The square root of 16 is a 4. Okay? So I'm going to go 0, 0. A half is 1. 2 is 2. 9/2 right here is approximately 4.5. So I'm going to go 1, 2, 3, 4, halfway in the middle, and that's going to give me a 3. And then I'm going to go to 8, 1, 2, 3, 4. Okay, now I know what some of you guys are thinking. You're going to be like, Miss Sorrells, that went higher, that's a vertical stretch. I'm not going to disagree with you. However, I want you to see what happened on the placement. The blue dot was here, and it moved this way. The blue dot was here, it moved this way. The blue dot was here, and it moved this way. It compressed, okay? So I'm going to just write it right here. That is a horizontal shrink / compress. The y distance got smaller, which means our x values changed. But what did they change by, you guys? And I tried to show it right here and right here. So I want you to think about what happened. The x values was divided, in our case, by 2. My x values had to be divided so that everything could work out. Okay? So let's go look at this one. Okay, and I'm going to have to move this just a little bit so I can show a little bit more work. Okay, so we're going to do the same exact thing. I guess I'll come along the side. If I have the square root of 1/2 x and I need that to be the square root of 0, that means what does x have to be so that I can get 0? Well, I want you to think about it. We have to multiply both sides by the reciprocal. So x equals 2 times 0, which is 0. So that means my x has to be 0 so that when I plug in 0, I get the square root of 0, which gives me 0. Okay? So we're going to do it again. The square root of 1/2 x, I need that to give me the square root of 1. So 1/2 x times what gives me 1. Okay, well, hopefully you have that number in your head, but if not, we multiply by the reciprocal. We multiply by the reciprocal, which means x had to be 2. So if x is 2, okay, square root of 1/2 times 2 gives me the square root of 1, which gives me 1. Okay, I think I'm going to have to zoom out a little bit more. Whoops. There it goes. Okay, so again, the next one would be square root of 1/2 x equals what to give me 4? So 1/2 x gives me 4. So what number could I take half of? Okay, so I had to pause the video for a second to let that music stop playing. But what I was saying is, what number could I take half of to give me 4? Well, hopefully you have that number in your head. But if you need to do the math, we are going to multiply by that reciprocal, so those cancel. So x is 8. So that when I plug that in, 1/2 times 8 is 4. The square root of 4 is 2. Okay? So that's all I'm going to be able to fit on this graph, so I'm not going to do any more. So we got 0, 0. We're going to have 2, 1. Okay? And then we're going to have 8, 2. So I know everything in here is a tight squeeze, so I'm going to zoom back in. But I want you to look at it, okay? Because I know some of you in your head are going to be like, but Miss Sorrells, that looks like a vertical shrink. And I don't disagree with you, but I want you to see what happened. This blue point moved from here to here. This blue point moved to here. So I want you to think about what happened. Okay, we have I'm going to try to squeeze it in here, a horizontal stretch, because I'm getting farther away. My y distance got bigger, and my x values changed. Okay, so what happens here is the x values were multiplied by 2. Okay, so if you come over at all this math, I had to multiply by 2 every single time. So when you're dealing with horizontal, I want you to see what happened. All of these columns, okay, those values did not change. But what did change was those x's. Okay, so I hope that maybe this example helped a little bit with the horizontal stretch and shrink. Please let me know if it didn't, and I can try to find another way to explain that. We got one more to do. Okay, this is your reflection over the x-axis and the y-axis. So again, I'm going to go put the original on there. 0, 1, 4, 9. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Again, I'm going to go put those on the graph. Okay. I'm just going to go ahead and highlight that one. And then there's that one. So notice the placement for my g of x with the negative. My negative is on the outside of that x. So notice I didn't change my x values. So let's just go plug them in. If I do negative square root of 0, well, that is still just 0. If I do negative square root of 1, well, the square root of 1 is 1, but that changes to a negative 1. If I do negative square root of 4, well, the square root of 4 is 2. That becomes a negative 2. If I do negative square root of 9, the square root of 9 is a 3, but that makes it a negative 3. Okay, I didn't have to change anything on the x side to get the numbers that I needed. 0, 1, 4, and 9 worked perfectly. But notice what happens. I reflected over the x-axis. Okay? So for these right here, we reflect over x-axis, and notice what changed. The y values did. Okay? Okay, let's go do this last one. Okay, but notice where the negative is now. It's the square root of negative x. Well, I need that to say the square root of 0. This one's a little bit easier to see because I would go negative x equals 0. Well, x would still be 0 because we would divide by that negative 1. Okay, so 0 would still give us 0. But notice what happens next. The square root of a negative x, I need that to be able to say 1. Well, negative x equals 1. So that means x has to be a negative 1 because we would divide both sides by that negative 1 to solve for it. So if I plugged in a negative 1, the square root of a negative, negative 1. Well, two negatives make a positive. The square root of 1 is 1. Okay. So let's look at the next one. Square root of a negative x equals 4. Because see, I can't just plug in a 4. I'm sorry, square root of 4. I can't just plug in a 4 because I can't take the square root of a negative. So negative x needs to be a 4. So when you divide by that negative 1 again, you get a negative 4. So that negative negative 4 makes a positive 4. The square root of 4 is 2. Okay, last one. Negative x has to be the square root of 9. Again, negative x equals 9. Whichever way you want to look at it, x would have to be a negative 9. So the square root of a negative negative 9. Two negatives make a positive. Square root of 9 is 3. So notice what happens here. We are reflecting over the y-axis. Okay, so let's go write down some things here. And notice I had to change my x values to make this work. Okay, so this one is reflected, so put an ED there, over the y-axis. So my x values changed. Okay, so basically here my x values ended up being opposite. Okay, so I'm hoping that this helps. All the purple notes that I made should line up with everything right here. So I tried to make sure I talked about this and this so that you can see how they all relate to each other. I hope this helped.